All right, so now we have an absolute value equal to an absolute value. So how do we solve this one? Well, it's going to be kind of by definition again. And so with the definition, what we're going to do is we're going to say, okay, we'll drop the absolute value here, 3x minus 4 equals. Now we'll drop the absolute value here, and that's going to be 2x plus 3. So that's the positive version. And then we can say or, and then we have 3x minus 4 equals. Now we want the negative of it, 2x plus 3. Okay, so we have, before we had the absolute value of x equals a, so we got x equals a or x equals negative a, and we're going to do the same thing here. So that's the positive a, that's the negative a. Remember, when we do this, we have to distribute that one over. So now what do we do? Well, let's subtract 2x. And if we want to do it at the same time, maybe we should get a little more creative here. Let's add 4. So those cancel, and we're left with 3x minus 2x is x, 3 plus 4 is 7. Now here we have to do a little bit of work first. So we have 3x minus 4 equals, now we distribute, that's a minus 2x, and then it's minus 3. So let's add 2x to both sides, and let's add 4 to both sides. So, that cancels that, that cancels that. So we have 5x equals 4 minus 3 is 1. Divide by 5, x equals 1/5. And so we have the 1/5, comma, 7. Okay, so that would be our solution set for this problem. Now this one's the same thing, except now we're going to have some fractions. So remember, if before we learned how to clear fractions, so I think that's probably what we should probably do here. So what we're going to do first is we're going to say, okay, well, this is going to be 2x minus 5 over 3 equals 3x plus 4 over 2, or, and then we have 2x minus 5 over 3 equals a negative 3x plus 4 over 2. Okay, so we have a 3 and a 2 in the denominator. So our LCD here is going to be 6. And it's going to be the same here as well. So I'm going to multiply by 6. And so, in theory, I could do that here as well. And when I do it, I'm going to have to remember distribute that negative at the same time in that case. So 6 times this, well, 3 will go into 6 twice. We'll have 2 times this. So we'll have 2 times 2x is going to be 4x. 2 times negative 5 is negative 10. Here, 2 goes into 6 3 times, so we have 3 times this. So 3 times 3x is 9x. 3 times 4 is 12. Okay. Now, maybe this time we want positive x's, so let's subtract 4x here, and let's subtract 12 here. So when we do that, that's gone, that's gone. So we have minus 10 minus 12 is minus 22 equals 9 minus 4 is what? 5x. Okay. So now what we do is we have to divide by 5. So x is equal to a negative 22 over 5. Or now when we do this, 3 goes in here twice. And guess what? We're going to get the same thing over here. We're going to get 4x minus 10 because it's going to be 2 times 2 is 4x. 2 times negative 5 is negative 10. But now it's going to be a little bit different here. So now we're going to have the same thing, but now we have the opposite. So instead of 9x plus 12, we're going to have 2 goes in here, 3. 3 times a negative 3 is a negative 9x. And then we'll have 3 times a negative 4 is a negative 12. So a little bit different. Now let's say we want to get a positive x again. So this time we'll have to add 9x. And this time we'll have to add 10. Okay, so that's gone. That's gone. So 9 plus 4 is going to give us 13x. Minus 12 plus 10 is going to give us a minus 2. Okay. So now we divide by 13. And so x equals a negative 2 over 13. So our solution set then is negative 2 over 13, comma, negative 22 over 5. And so that would be our solution to this problem here. All right, we got this one now. And here again, we have to get rid of everything but the absolute value. So first things first, let's subtract that 7. Because remember, we're doing PEMDAS in reverse. And so that's gone. We have minus 6 times absolute value of 4x plus 1. And then these are both negative, so we can add. And so that's equal to a negative 42. Now we're going to divide by a negative 6. And so absolute value of 4x plus 1 equals, well, 42 divided by 6 is 7. Negative divided by negative is positive. So we have a positive 7. Now, at this point, we can drop that absolute value. We can say 4x plus 1 equals 7, or 4x plus 1 equals negative 7. Well, subtract 1. Now we're back to forward PEMDAS. We have 4x equals 7 minus 1 is 6. Divide by 4. X equals 6/4. But we can reduce that. 2 will go into both of these. 2 will go in that 3 times. 2 will go in that 2 times. So 3/2 is actually the fraction we want to use in this case because that's the reduced form. What about this one? Well, if we subtract 1, we get 4x equals minus 8. Divide by 4. X equals, now it's a minus and it's a 2. So our solution set is a minus 2 3/2. Okay. All right, so now we're back to this one where we have absolute value equals absolute value. So we're going to say, well, 4x plus 4 equals 8x plus 3, or, and then now we have 4x plus 4 equals negative 8x plus 3. Okay. And so when we do that, what do we have? Well, we subtract 4, and here we can say subtract 8. We're going the opposite direction this time. So those are gone, those are gone. So we have 4x minus 8x is minus 4x. 3 minus 4 is negative 1. Divide by negative 4. X equals 1/4. Okay. Now here we have to distribute first. So we have 4x plus 4 equals negative 8x minus 3. So now let's say we subtract 4, add 8x, add 8x. So we're doing 2 steps at once again. Now 4 plus 8 is 12x. Minus 3 minus 4 is minus 7. So divide that by 12. X equals a negative 7 over 12. So our solution set is negative 7 over 12, comma 1 over 4. Now, one thing I've sort of failed to do this whole time is actually check any of my answers. So what we're going to do this time is we're going to actually check the answers. And what we have to do is we have to plug both of those back into this original equation. So we have absolute value of 4 times, let's do the negative 7 over 12, and then plus 4 equals absolute value of 8 times negative 7 over 12, and then plus 3. And so now let's do some cancellations. So let's keep track here. 4 goes in here 3 times. 4 goes in here twice. 4 goes in here 3 times. So now what we have is absolute value. Well, that's going to be a negative 7 over 3 plus 4 equals. Now this one's going to be negative 14 over 3 plus 3. Okay. Well, now we got to get a common denominator. So we have to multiply this one. Let's put a different color here so we know what we're doing. Let's multiply this by 3 over 3, and this one by 3 over 3. And so we get a negative 7 over 3 plus 12 over 3 equals, then we have a negative 14 over 3 plus 9 over 3. And so here it looks like we have 12 minus 7, which is 5 over 3, absolute value, equals, and here we have 9 minus 14, so that's going to be that's negative 5 over 3. Absolute value, that's 5/3. Absolute value, that is 5/3. So that checks out. Now I've ran out of room for the other one, but let's see if we can squeeze it in here. Let's kind of maybe get rid of our or. And so we're going to have, well, let's put it maybe here, 4 times 1/4 absolute value plus 4, and then equals absolute value of 8 times 1/4 plus 3. So let's change and get our reds out again. So that goes into here. That's 1, that's 1, that's 1, that's 2. So it looks like we have 1 plus 4 is 5 equals 2 plus 3 is 5. 5 equals 5, so it checks as well. And all the rest of these we should have been doing, but I was noticing I was running out of room. I thought I might have enough room on this one, but I didn't. So, but that's what we really need to be doing all along. So all the ones we've done up to this point, you should always do a check to make sure that both answers really do work. And so you have to work it all the way down until you've gotten rid of all of the absolute value signs, and then you have some number equals some other number, if you did it right. All right, what about this one? Did I just do that one? Yeah, I did that one already. I don't know what's it for, so we won't do that one. All right, what about this one? Well, I'm just going to say I have 5x plus 2 equals 14, or 5x plus 2 equals a negative 14. So I'll have to subtract 2. 5x equals 14 minus 2 is 12, divided by 5. X equals 12 over 5. Or now I have to subtract 2. And so 5x equals, that's going to be a minus 16, sorry. All right. And so divide by 5, and x equals negative 16 over 5. So my solution set is negative 16 over 5, comma, 12 over 5. Now this one maybe we better check just because I was making a mistake there. Maybe I made a mistake elsewhere. So we're going to take absolute value of 5 times. Now we'll take a negative 16 over 5 plus 2 and equals 14. Well, if we cancel out what we need to, that goes and that goes. So we have the absolute value of negative 16 plus 2 equals 14. That's going to be the absolute value. Well, subtract 2 from there is 14. It's a negative 14. And so 14 equals 14 after you take that absolute value. So that one works. What about the other one? Well, we're going to have absolute value of 5 times. Now that's 12/5. And then plus 2 equals 14. Well, again, we can cancel that. And so we get the absolute value of 12 plus 2 equals 14. Absolute value of 14 equals 14. And absolute value of that is just 14. And I don't know why I have 2 ones there. All right. And so that one checks as well. Okay, so both solutions do work. And that's all I have for this section.